Hello everyone, welcome back to the channel. In this video, we are going to implement queue using stacks. Earlier, we have implemented it using array, right? In this video, we are going to do the same thing using stacks. So we are going to do this using help of two stacks, right? So let's see how we do that. So we have taken our first stack as stack 1 and another one as stack 2. Now let's create our enqueue method. Public void enqueue. You want to add this item. Now what do? We straightforward add that in stack 1 item. And you believe me or not, the enqueue or add method is done using when we are trying to implement the queue using stacks. Now the real logic will be in dequeue method. Let's see that. Public int dequeue. So let's start with our dequeue method. What do we want to check? If our stack 2 is empty or not. If it is empty, right, then we want to take a loop. What you want to do basically, when your stack 2 is empty, right, you want to shift all the elements from stack 1 to stack 2, right? So that when you're trying to remove the elements, right, they will remove in the order in which they were inserted. They will follow that FIFO order. Let's see how we do that. While stack 1 is empty, while stack 1 is not empty. So while stack 1 is not empty, what do we want to do? We want to push to stack 2 all the elements from stack 1. Perfect. And in the end, what do you want to do? You want to return from stack 2 dot pop. Okay, so we have that in place. I mean, when we are removing from our queue, right? So if your stack 1, stack 2 both are empty, you actually have no elements to dequeue, right? No elements to remove. Let's add that condition as well. So if stack 1 is empty and your stack 2 is also empty, in that case you want to throw an exception telling that queue is empty. That's correct. Let's extract this condition. Is empty, and now we can extract this as well. Let's extract this and give it a name like move items perfect. Okay, so now we know what we are doing here. Yeah. Now we can implement one more method, that is peek method, right? Let's implement that. I think that will be very similar to our dequeue method. I'm just changing the name, and that's it. You have your peek method as well. Let me show you that by having a demo of all these methods. We don't need to do that. Perfect. So we have created an object for our queue dot enqueue. Let's add two more values, 20, 30. Now as per the concept of queue, right, when we are trying to remove this, we are supposed to get 10 for the first time, because if you know that queue follows the first in first out order, right? So first 10 was inserted, and we are trying to remove now from our queue. We are supposed to get 10 as part of the removal. Let's see, we are supposed to get 10 only, and we are getting 10. And if we try to do that again, we are supposed to get 10 and 20 for the second time. Perfect. That means our implementation using two stacks is working perfectly fine, right? This is perfectly fine, there is no problem. Now let's try that peak method as well. So currently you have only 30, right? So in your queue also will return 30 only. So you're able to see, right, using two stacks, it was very easy to implement this queue data structure. Just go through these methods to understand how we utilize these two stacks to implement this queue. And in next video, we'll be implementing a priority queue as well. So priority queue has concepts of, adding and removing values based on its priority. That we are going to see and implement in the next video. For now, as part of this video, we have seen how you can implement queue using two stacks. It was very easy to implement. Just go through the code once, and that's it. That's all as part of this video. See you in the next one. May the source be with you.